Hello. Today we're going to talk about 6.5, Solving Radical Equations, Part 2. So for this one, we're going to be solving exponential equations. Alright, so for number 1, we could reinterpret x to the 1/3 and rewrite that as the cube root of x to the first equals 3. Well, then notice all we have to do to get rid of the cube root is just cube it. So we get x to the first equals 3 cubed. Therefore, x equals 27. Which makes sense because when you plug that in, 27 to the 1/3 is 3. Okay, because that's, again, the cube root of 27 is 3. All right, let's do number 2. So here we can rewrite this as the square root of x to the first. So to move that to the other side, all we would need to do is square it. So here we get x equals 16. Okay, which again makes sense because 16 to the 1/2 equals 4. Okay, you want to get comfortable or start getting comfortable with fractions as exponents. All right, you're going to see these, it's going to come up, you want to know what they are, okay, and how to handle them. Okay, another way to think of these is instead of rewriting them as radicals, we could just kind of skip a step and go, okay, we raise the other side, okay, to the power of this denominator. So this denominator was 3, so we raise the other side to that power. This side was let me change the color. This side was a 2, so we raised the other side to a 2. That's just a little shortcut. All right, so here for number 3, okay, one way of looking at it is saying the cube root of x squared equals 4. Therefore, 4 cubed is x squared. So that's just, let's see, 1664. And then all we need to do here is take the square root. All right, remember when we take the square root, we have to do plus or minus. Anybody know why? Yeah, all right, because we have to remember that 8 squared equals 64, but also negative 8 squared is 64. A lot of people forget this, so I'll just keep on explaining it. So whenever you put the square root there, you have to put plus or minus. So here we get plus or minus 8, 2 answers. Okay, which makes sense. All right, if we plug that in, both of them are going to work. So we get 2 answers. Alternatively, you could have thought of it as, let's see, so if you have x to the 2/3 equals 4, all we had to do is raise the other side to the 3rd power and then take the square root. Okay, I'm sorry, we took the square root, got to put plus or minus. Ooh, almost forgot. All right, so another way of looking at this is saying the square root of 4 cubed, which is 2 cubed, which is 8, which is kind of nice because I was able to do that in my head, okay, as opposed to going this way. You know, the numbers might get too large. It might be a little bit harder for me to do in my head. Okay, so just another way of looking at it. All right, so let's do number 4. Okay, there's a lot of ways to go about this, okay? One way to think about this is all we're doing is flipping the fraction, right? We're reversing the order. Instead of taking the cube root and squaring it, we're doing the opposite to the other side. So think I want to raise this negative 2 to the negative 1/2. Why would I do that to both sides? Because when I raise a power to a power, I multiply. So negative times negative is positive. 2 times 1/2 is 1. So x, there we go, I got x by itself, equals 49 to the negative 1 over 2, or the square root of 49 to the negative 1. What was that? Oh yeah, I put the square root there, so I need to put plus or minus. So here, x equals, well, plus or minus 7. Anything raised to the negative 1 is just, you write this a little bigger, is just 1 over that. Okay, I went through a lot of steps there. Okay, so raise it to the opposite reciprocal, right? Because you want to multiply those numbers together and get 1. Okay, raise that to the other side. Whenever you put a square root there, an even root, you have to put plus or minus. Let's do some more. It's very similar to when we did radicals. All right, so hopefully you thought that. And we want to get this by itself. So let's get rid of this other junk. Get rid of that 6. Okay, because all I have to do is subtract it. Get rid of that 4. All I have to do is divide it. Get rid of this exponent. Raise it to the opposite reciprocal. So that was negative. Why do I keep saying opposite? I want to keep the sign the same. Reciprocal. Negative times a negative is positive, and 1 over 4 is 4 over 1. When I multiply, I'll get 1. All right, so I know that's the exponent I want. So now let's raise this, well, to the negative 4. So that's 1 to the negative 4, 4 to the negative 4. I don't like negative exponents. We'll just flip that. 4 to the 4th over 1 to the 4th. That's a little easier to do. So let's see, that's 2 to the 8th, 256 over 1. There you go. All right, number 6. All right, I can't get the x by itself, but I do have the exponent part by itself. So let's raise this part to the opposite. So 3 over 2, the reciprocal. Sorry, I don't know why I keep saying opposite. It's a bad habit. I don't know. So 2 over 3 times 3 over 2 would just be 1. And that's what we want. Okay, because anything raised to the first power is just itself. So whatever we did over here, we got to do the right side. So raise 4 to the 3/2, square root of 4 cubed. So I get 2 cubed, which is 8. Move the 1 over, I get 7. Wait, hold on. Ah, yes, I put the square root there. Should have been plus or minus. So this is when it might get a little tricky, right? You have two numbers, okay? Don't lose them, okay? You have one where it is positive 2 cubed, and then you have another one where it's negative 2 cubed, right? Because it was all of this. Okay, so it might be easier to split it into two equations. So this is x plus 1 equals 8, so x equals 7. X plus 1 equals 8, x equals 7. Okay, we got the same answer here, okay? That's not always going to be the case, all right? But that's reassuring, okay, that I was on the right track. Wait, no, what did I do? Oh, dang it, I messed up my negative. Negative cubed is a negative 8. I hope you guys caught that. God, I hope you're smarter than me, all right? Goodness, guys. All right, so we subtract the 1, and we get negative 9. We get 2. All right, we want to plug them back in, see if they work. Let me see. All right. If you plug them both in, they both should work. All right, so go practice. All right, ask me questions. I know this is weird. There's a lot of rules to follow. All right, just go with your instincts. Just try something, okay? If it doesn't make sense, try a different property, okay? If you get lost, ask me. I'll be happy to go through these. I know it can be a little confusing, okay, or a lot of confusing.